the talk is going to be about these three different words. The first one is the Trans-Mexican Volcanic Belt, a comparison with the volcanism of the central volcanic zone of the Los Andes. We are comparing the type of volcanism and the probability of eruption there in these two volcanic zones. Later, I will show you a methodology to assess risk in a monogenetic field. So through this case of studies, one is from Michoacán, Guanajuato volcanic field, and the other one from Chichinautin volcanic fields. These are in Mexico. And finally, I'm going to show you a methodology to assess risk in this polygenetic volcano in Chile, in the southern Chile. It is this complex called Planchón Peteroa. So to start with this presentation, just let me show you where are the areas that we are talking about. Let me, yeah. So the Trans-Mexican Volcanic Belt is this big area that crosses Mexico from the east to the west. So there are about 3,000 volcanoes there between monogenetic and polygenetic. And the other area is this one from southern Peru to northern Chile. It is involved there are involved these 4 countries, Peru, Bolivia, Chile, and Argentina. So there are about 2,500 volcanoes. So the number of volcanoes is more or less the same, but the areas it varies a little bit. So what are the similarities and the difference between these two areas? So here you can see a summarize of several similarities and differences, but I want to highlight this. The area in the Trans-Mexican Volcanic Belt versus the area in the central volcanic zone of Los Andes. So the area in the central volcanic zone is almost twice as the area in the Trans-Mexican Volcanic Belt. The population living in this both area has a lot of difference also. There are almost 47 million people living in the Trans-Mexican Volcanic Belt, versus less than 2 million people living in the central volcanic zone. So you can see the density of people living in this area that is the half of the area in the Los Andes. And the number of volcanoes is more or less the same, with about, as I told you before, 3,000 volcanoes. So talking about monogenetic volcanoes, the density of volcanoes is almost twice in the Trans-Mexican Volcanic Belt and in the central volcanic zone. So the last eruption of the monogenetic type happened about 80 years ago in Michoacán, Guanajuato, versus in the central volcanic zone almost 500 years ago. So talking about, when we talk about the polygenetic volcanism, there are also some important difference. The number of polygenetic volcanoes that have been erupting in the last 1,000 years is 6 when we talk about just volcanoes. So in the Trans-Mexican Volcanic Belt is 6 versus 14 in the central volcanic zone. The number of eruptions are more or less the same. When we talk about the Trans-Mexican Volcanic Belt, we have 20 eruptions with BI equal to 3. So against 23 of this type of eruptions in the last 1,000 years. Talking about the BI 4 or more of Holocene volcanoes, we have more or less the same. So the difference here, it is mainly in the number of active volcanoes. So we have more volcanoes having more or less the same eruptions, whereas in the Trans-Mexican volcanic belt, we have only 6 volcanoes having more or less the same eruptions. When we talk about Pleistocene volcanoes, this is more dramatic. So we have only in the Trans-Mexican volcanic belt 19 versus 75 in the central volcanic zone of Los Andes. So we did this research in order to try to evaluate the hazard related to this type of eruptions and volcanoes. So here are the volcanoes from the Trans-Mexican volcanic belt. We first of all we did a density analysis to try to figure out where are or how the volcanoes are distributed. So we found that there are 15 clusters or 15 monogenetic fields in the Trans-Mexican volcanic belt, and about 9 Holocene plus 19 Pleistocene polygenetic volcanoes that are separating these clusters. So we can find that, for instance, here, this is the Michoacán, Guanajuato monogenetic volcanic field. So this is kind of the largest concentration of monogenetic volcanism on Earth. So we have 1,000 volcanoes just in this area, where it is not possible to find polygenetic volcanoes, or active polygenetic volcanoes within the area, but are separating other monogenetic fields. So the next field is to the east is this one, and then we arrive to Mexico City, where we have the Chichinautzin volcanic field. So what we find here is that these polygenetic volcanoes are separating the monogenetic fields, and also, the fault systems are kind of different. When we analyze the distribution of these monogenetic fields, we find that most of the monogenetic fields are distributed following this trend that is east to west, and the polygenetic volcanoes can be found in the fault system that have a trend north to south to north, or north to south. So this is one of the main characteristics that we find here. So this is the analysis that we did, trying to figure out how these volcanoes are distributed. So we found these 15 different concentrations, and as I told you before, they are separated by these different fault systems and by the stratovolcanoes. We did this analysis also. That this is a statistical analysis. It's a clustering analysis to basing on the distance of each bend, separate or congregate, better say, the volcanoes in clusters. So we did this analysis with density analysis, with this kernel analysis, and this agglomerative analysis to recheck our findings. So what is happening in the central volcanic zone of Los Andes is more or less the same. We find here 21 monogenetic clusters separated by these polygenetic volcanoes. What is interesting here is that more of the volcanoes that are separating these different clusters are volcanoes with eruptions less than 1,000 years. So it seems like this distribution of these fields is really controlled by the fault systems, of course, and by the distribution of the polygenetic volcanoes. So there is a relationship between the distribution of the recent eruption of polygenetic volcanoes and the distribution of the monogenetic fields in both areas in the Trans-Mexican volcanic belt and in the central volcanic zone. So when we compare the recurrence rate of all these type of activity, we find that based on the recurrence rate of the BEA more than 4 eruptions, we find that in the central volcanic zone, there is a higher probability of having eruptions with this BEI, and also for BEI equal to 3. So the distribution of the probability is higher in the central volcanic zone for this two type of explosive activity. But in contrast, the monogenetic volcanism recurrence rate is, and the probabilities is higher in the Trans-Mexican volcanic belt. So what this means, that a probability of monogenetic eruption is higher in the Trans-Mexican volcanic belt, and the probability of polygenetic eruption higher than 3 is also higher in the central volcanic zone. So what we can expect is that eruptions in the central volcanic belt, in the central volcanic zone, would be, of course, from a polygenetic volcano and would be higher than 3, whereas the probability of monogenetic eruption in the Trans-Mexican volcanic zone, also we can expect more kind of monogenetic activity in the Trans-Mexican volcanic belt and in the central volcanic zone. So based in these findings, we decide to assess this risk, the risk related to monogenetic volcanism in these two areas where we have been, there have been activity, historical activity. So as I showed you before, here is the Michoacán, Guanajuato, and here is the Chichinautzin volcanic belt, volcanic field. So we have more than 1,000 vents in Michoacán and more than 200 vents in Chichinautzin, that is close to Mexico City. And these two volcanic fields are parallel to the trench that is here. So first, we start with the Michoacán, Guanajuato volcanic field, and we found that the volcanoes with, talking about just the cones, the scoria cones, so the volcanoes of the scoria cones are more eroded in the northern part of this field, whereas are less eroded in the central part and in the southern part. So we did this statistical analysis just with the distribution of the relationship between the base and the height of these cones to try to figure it out where are the younger and the older volcanoes. So as we found here, so the volcanoes in this part of this field are, as I told you before, more eroded, which we can say that they are older, whereas in this central part, the volcanoes are less eroded, so we can say that these scoria cones mainly are younger. So the last eruptions that we have here are in this part. So this is a Paricutin volcano, that is the youngest volcano in Mexico. And here is also a Jorullo. So the most recent events in this area are these two volcanoes. So we did this same analysis, the Venn cluster agglomerative dendrogram. So we can see here how this statistical analysis shows how these different groups are forming just based in the spatial distribution. So here is the different groups that are forming the Michoacán, Guanajuato volcanic field. And here is, of course, separated the Chichinautzin volcanic field. So we conclude in this study that the Michoacán Guanajuato volcanic field is actually a superfield. We decided to call it like this, a superfield made of 4 different fields that we decided to name it as are here. So we also did this analysis of density. So the density of volcanoes allow us to see how these volcanoes tend to agglomerize it in these different areas. So we can clearly separate this, in this case, these 3 fields, and the northern part of the field is completely different. Not just talking about the let's say the age of the volcanoes, the spatial distribution of the volcanoes, but they are also placed in different fault systems, or at least different fault systems directions. So from this analysis, you can see here, for instance, this is that the field that we decided to call Valle de Santiago volcanic field is placed in this system, the Alberca Tremendo fault system, that has this trend. And if you see, for instance, in this other field that is the Aganguan, have also a different fault system trend, and fault system belongs to different fault systems. The same for the Uruapan and the Pátzcuaro. So with this, we separate this big field, big super field in 4 different fields. So we are currently doing more research on, variations on chemical composition, and we are trying to do more dating, so we can reinforce these findings. So since there are a lot of seismicity in this area, we also decide to analyze the distribution of the seismicity, especially in these years from 2020, when a swarm of earthquakes began. So we have these swarms almost every year since then. And what we found is that there is a migration also from seismicity from the east to the west, and also we have variation in depth. So the most recent earthquakes are also the ones that are shallow. So it is, in this case, maybe related to a migration of magma from somewhere in this area to somewhere to this other area. So we are not completely sure if a next volcano is about to burn maybe here. So we will see in the next years. So in the case of Chichinautzin, what we did was to separate also the different periods of activity of the Chichinautzin volcanic field. In this case, we studied this number of eruptions that have occurred in the last 35,000 years. So these are the most recent eruptions. Here is Mexico City. Actually, in the main part of Mexico City live about 9 million people, but in the Med area of Mexico City live about 25 million people. So the problem is that this is one of the Chitle volcano. It is one of the most recent eruption that actually impacted the old Mexico City. So future eruption that is probably here, in somewhere here, could of course impact the area. So we have more dating here and more analysis of age in this field. So we decide to estimate, probabilities from these different ages. So what we can see here is that based on radiometrical dating, we estimate ages for those volcanoes that we don't have dating. So we found that the most older volcanoes are located in the east part of this field, and the most recent eruptions are located in the western of the field. So it seems like most recent eruption is located mainly in the north western part of the field. So we did this probability analysis, so that we call spatiotemporal probability. So we found that these three areas, this one, and this one, based on the distribution and in the age of the volcanoes, are areas with the highest probability. We also did this analysis to try to find the the feeding dikes that can be feeding the eruptions. So we did this with just the distribution of the most recent eruption from 10,000 years to the present, and we found that the main direction of like it seems to be the feeder dikes are more or less parallel to the trench. So based on this, we proposed three different scenarios from eruptions, also based on the most common eruption in each area, that are these ones. In the scenario A, we propose an strombolian to violent strombolians, since the eruptions in this area are more or less prevalent like this. Then Santiaguito type eruptions, that is the emission of a thick lava flows in this area, that it is more common. And in this area, that is the central part of the field, that it seems like we have a different controlling system from faults. We propose an strombolian, a Hawaiian to a strombolian eruption there. So we did a tephra hazard map and lava hazard maps from these areas. And then we contabilize, we recount the number of exposed elements. So we count the population, houses, transportations, hospitals, schools, natural and cultural heritage that are exposed in each of the different scenarios. And then we construct these curves to analyze vulnerability. So in the case of ash, we propose that everything that is exposed to more than 20 centimeters to ash can be affected. Of course, if the thickness of ash is more than 90 centimeters, is of course destroyed. And in the case of lava, we propose that everything that is exposed to more than 2 meters of lava can be completely destroyed. So we did this vulnerability maps of the main part of Mexico City. So we did this analysis based on these indicators, that is a housing density, type of floor, electricity service, sewer service, fresh water, population density, number of kids, adults, etc. So we did this vulnerability map, and then we construct this matrix of vulnerability. What we did here is to compare the hazard maps with the vulnerability maps, and then to propose these different risk assessment. So in those places where we have high vulnerability and a high hazard probability, so the risk is of course very high, and so. So we did this TEFRA and risk maps. So here you can see that in the scenario A is the main scenario with most ash emission or TEFRA emission actually. So the risk maps looks like this. And in the case of lava map of risk, the lava, the lava risk map, it looks like this. So the worst scenario is this one, that is the scenario 8, in which there are a lot of population and a lot of infrastructure exposed and with high vulnerability. So we also perform this direct cost analysis to try to analyze the cost of the eruption, the direct cost, based on the cadastral prices of the infrastructure that is exposed. So we find that the scenario is also the one that is the one that has the higher cost of the eruption. We're not considering an indirect cost of this. So in the case of the Planchón Peteroa, the approach is different. We are working there since this year, since January of this year. So Planchón volcano is located in the central part of Chile. And we are studying this small community that's called Los Queñes. It is a community of about 254 inhabitants in winter and up to 1,000 tourists and visitors in summer. So this is very important because since there is a remote community with these two rivers, the communities in the middle of these two rivers. So the main hazard here is debris flows and lahars from Planchón that are normally placed through these ravines, the Claro River and the Teno River. So last year, there was a disturbation on the atmosphere that caused a lot of rains. So we have extraordinary rains in this area that impact the community. So this led us to try to do this analysis. So in the last year, there were 8 homes destroyed that they were located in these 2 areas. This was the main that were destroyed. And in January of this year, we went to try to do this vulnerability analysis based on fieldwork. So we do the exposure analysis, the evaluation of the physical condition of the homes and infrastructure, and a population survey. The support of this community radio was very important since we contact them to explain how we'll be working there and the goals of our study. So they help us to talk with people. So the people were waiting for us actually. So this facilitated the study. So we prepare a survey to assess socioeconomical aspects as a presence of children, of adults, of people who don't speak Spanish, illiterates, handicaps. This is from the social perspective. From the physical perspective, we evaluate architectonical aspects such as the presence of foundations in the structures, structural system, walls, roof, the presence of basic service, age of the construction, and other aspects, in total 20 parameters. And we also did this risk perception survey to score how people beliefs can be incorporated in our social analysis, to try to find out how people would respond to the hazard. So we did three different studies. So we also, of course, did this exposure analysis, that is the inventory that, of elements at risk. So here is a zoom of the community. It is a really small community in the middle of these two rivers. The river that is more active to debris flow and lahar is this one, that is called Tenor River. Here is where the houses were destroyed last year. So there are, as I told you before, about 1,000 people in summer mainly, and we have there 500 homes. So, 500 buildings, considering also hospitals and stores, etc. So we did this in every building. So we assume the scores that we assign to the different parameters that we evaluate, and this allows us to identify buildings with high or very high vulnerability. So of course, these are the destroyed buildings, and also some neighbors around there. But also in this central zone of the town, there are buildings with high vulnerability. In the case of the social parameters that we evaluate, we decide to do it like this. So we find that there are about homes with 74% of the homes have children with of less than 5 years old. Oh, sorry, it is here. And also in more or less the half of the homes, there are elderly. So the social aspects of the community are difficult. So it is a remote community in the middle of the Andes. So the next population there is about more than 1 hour driving, and as it happens in the last year, the roads were destroyed. So the conditions of people living there are difficult, and also, of course, the vulnerability. And what we find with this perception of risk analysis was more or less they were, of course, as it happens normally in some places, when you ask people if they were willing to evacuate, they say yes, but in the last year, most of the people they didn't want to evacuate. So we find, contrasting aspects here. So the level of knowledge also about the hazards are variable, since, for instance, of course, they don't know almost anything about volcanic hazards, but they know, for instance, a lot of what is inundation, what is a flood, sorry, or what is a debris flow. So we still trying to analyze this contrasting information, but what we think is that the most of people have a perception of the risk that needs improvements, and some of them have a perception of risk that it is wrong, or it is not correct. And only 36% of people has an acceptable level of perception of the risk. So we think that the main problem here is that people has invade or has placed their homes in places where their homes has not to be, like those that were destroyed last year, that were actually placed in the wetlands of the river. So this is a problem because, of course, people are going upstream, exposed, and they are more exposed to debris flow and floods, and so. But what is for us, what is more important, it is this all this area where the two rivers are joining. So we think that, of course, the territory needs to be ordered. So to finalize, the future work that we will be doing is construct eruptive scenarios in the volcanic fields for Uruapan mainly, to try to do the same research that we did in the Chichinautzin, to construct eruptive scenarios in the central volcanic zone of Los Andes. In the case of the Planchon volcanoes, integrate a hazard simulation to generate risk maps, and in all the volcanic areas to do some education and awareness campaigns, to propose risk mitigations, and of course structural and non-structural mitigation measurements. So thank you very much.
Awesome work, Amiel. Thank you for presenting. Now we are opening the space for questions. If anyone has a question, feel free to unmute yourself or type it in the chat box. Well, I do have a question, actually.
Yeah.
For the Michoacán, Guanajuato volcanic field, there's these 4 different subdivisions that you showed. Are they, and they have these different tectonic settings. I also wonder if they have different petrogenetic setting.
Sorry, I didn't understand the question.
Oh, like, do they also have a different magma genesis? Have you been able to see if they have different compositions or things like that?
Yes, yes. It seems like in the north part, the volcanoes, I didn't mention that, not just different magmas and different genesis of magmas, that these have been studied before from other authors. So yes, the magma in the north part is completely different than the magma genesis in the southern. And also the volcanic styles that I didn't mention. In the north part, there are more maars and more phreatic eruptions than in the southern part. Yes.
Thank you. Do we have any other questions? Okay, well, we wait for more questions. Oh, actually, Joanna has a question. You can unmute yourself.
Okay, so thank you so much for your presentation. That was really awesome. I was wondering, so what, I know that this would be like future work, but what kind of like hazard or I guess education, what kind of hazard education would you be thinking about, especially for like your non-Spanish speakers, and if like the non-illiterate, does that include, like, how much of these areas have like indigenous groups, and are those like indigenous languages? Does that account for the number of people that don't speak Spanish, or like, is that yeah, is that question sort of clear?
Yeah, that that's a difficult one. Thank you for the question. Yes, of course. What we did for instance, in Planchon volcano, this is a more touristic area. So we went with the, touristic authority to told them about our plans of them working there. And, the community radio also helped us a lot because they have plans to translate for tourists, the hazard maps that we were working on. So they try to put these maps in the entrance of the town, of the community. So to go to this community, you have only two options to go there by two roads. So you have to go through a bridge. So it is a narrow bridge. So they plan to put the hazard map both not just in Spanish but also in English, and in one of the these languages. I forget the language that is the rural language there, but yeah. So that's for the moment the plan, just to try to translate the hazard maps.
Thank you.
Yeah, thank you.
I mean, there's we have Darren who has a question.
Yeah, Michael. Oh, sorry.
Yeah, sorry. Thanks for the talk. Really enjoyed it. So, Amiel, I have a question. So, when you assess the spatio-temporal hazard, I noticed that you use recurrence intervals, and then at some point you showed like a seismic map. So this field of yours is a little bit foreign to me. I'm a volcano seismologist, so I'm curious. You use recurrence intervals to kind of quantify temporal, the temporal variation of hazard, or like the temporal aspect. But I'm curious if you are, would you explore maybe using like a near real-time hypocenter catalog to kind of get added granularity of hazards? Because for me, I feel like when I look at volcano seismology, I look at earthquakes per week or per day in the lead up to an eruption. So I'm curious if you would explore like a finer granularity of that.
Yeah, that was a tough one. Yes, in the case of Michoacán, that is the volcanic field where we did this seismic analysis. We don't actually have permanent stations. So we have the network of seismometers is really weak. We don't have enough seismometers. Actually, I know from Mexican government receive help from the U.S. Through these agencies. So they sent some seismometers to be placed there, but I don't know if they were actually placed. As far as I know, the network is still incomplete. So what have been done there is through the National University, they place some mobile stations near the Paricutin area, but we are far from talking about, real seismic monitoring analysis. Yeah. No, we are far.
All right, thank you. I understand there can be challenges in that regard. Thanks.
Yeah, thank you.
Okay, we have one more question from Michael in the chat. With potential infrastructure damage from hazards, how are you thinking about measuring evacuation preparedness or evacuation timelines?
Yeah, in the case of Planchon, where there are these two rivers, the Claro and the Tenor rivers, we are working on the early warning system from lahars and debris flow that we place there. Actually, it is working. It is still on experimental, but we place a seismometer and a camera, video camera. We have no real time we have to go to pick up the information, but this is still in the experimental stage. So maybe we are what we are trying to do is to characterize the seismic signal from the lahars and from debris flow to try to set umbral how you say umbral
Threshold.
yeah, thresholds. Yeah, thank you. To try to set a threshold in order to place a early warning system. Yeah, that is our idea. Maybe in the next years, it could be reality.
Nice. So it seems like we don't have any more questions. Before we go, I want to say that the next session for our webinar in 2 weeks on October 15th is canceled. So we're just gonna skip that and go to the last one, which is on October 29th. So we're gonna send you or send an announcement on the Volcano listserv and the other channels that we use for this. Since it seems like we don't have any more questions, thank you again, Amiel, for joining us on this webinar series.
No, thank you.
Yeah, for everyone else, we'll see you on October 29th.